This video is on how to set up a DOE in Quantum Excel. The process that we'll use as an example is the dual cup virtual catapult that you can see on the screen right now. I will post the link in the description, but if you just Google dual cup catapult, you'll find it quite easily. The dual cup catapult has many factors that are similar to an actual catapult. So for example, I can change the cup elevation, I can change the bungee position, and the bungee is this red line right here. Think about a really big rubber band. This is the pin elevation, and this is the firing angle. If I want to shoot the catapult, then I can pull the arm back, click and drag with my mouse, and I pull it back to the desired angle, and then I release the mouse, and then the catapult will shoot the balls. In this case, it looks like the red ball went about 339, and the blue ball went about 320. There is no unit of measure on this. For the purposes of DOE, it doesn't really matter as long as we're consistent. This could be centimeters, inches, meters, fathoms, parsecs. It doesn't really matter as long as it's consistent. When I click on fire again, I can adjust the factors one more time. So for example, if I wanted to see the balls go a very different distance, I rotate the cup rotation angle to 90 degrees. Now the red ball has gotten higher and the blue ball has gotten lower, and therefore the red ball will depart with more velocity and therefore go further, whereas the blue ball will not go as far. So for example, if I pull back and I shoot the balls, we can see now that the red ball in this case has gone about 309 and the blue ball has gone about 264. The factors that we're going to experiment with for this demo are going to be the cup rotation angle as well as the firing angle. Because the firing angle is going to affect the angle that the ball departs the catapult, the angle that the ball is going to depart the catapult is going to have some nonlinear effects, and so I'm going to go straight to a nonlinear DOE. We're going to end up doing a central composite design. All right, the factors that we're going to experiment for this are going to be the inputs, which are the firing angle and the cup angle. There are many different names for this in DOE. So inputs is a generic name. We would also call the inputs, firing angle and cup angle, independent variables. That name is much more popular in academia than it is in industry, but nonetheless it's a completely valid name for an input. And it's often called a factor as well. The outputs are going to be, which are sometimes called the dependent variables, and are also called responses, are going to be the distance that the blue ball goes and the distance that the red ball goes. And our objective is to build a model for how far the blue and red ball will travel as a function of the firing angle and the cup angle. To set this up in Quantum Excel, we click on the QXL DOE ribbon, and then we click on Design Wizard. Now there'll be other videos later about how we create this manually. If you know what you're doing and you know exactly which design you want from the beginning, you don't have to use a Design Wizard. You can jump straight to the type of design you're interested in on the right. But for now, let's go ahead and use the Design Wizard. When I click on the Design Wizard, Quantum Excel is going to ask me how many levels. Because of the curvature associated with the angles that we're working with, I'm going to jump straight to a 3-level design. The reason for that is deductive reasoning, engineering knowledge indicates that there is going to be curvature due to the fact that there's an angle. Whenever there's an angle, the ball is departing the catapult at the sine of theta. The sine of theta is not going to be linear, therefore a 2-level DOE would not work very well. I'm going to jump straight to a 3-level DOE. Then it's going to ask me the number of factors. In this case, I have 2 factors, so I don't need to change anything, and I click Next. Quantum Excel then says, do you have any qualitative or categorical inputs? So qualitative and categorical inputs are things that are not quantitative. They don't have a direct scale. So temperature, voltage, humidity, those are all quantitative. Things like vendor, day of the week, those are qualitative. It actually turns out that some DOEs, for example, the central composite design and the box Binkin, cannot be used with categorical or qualitative inputs. Therefore, I need to tell Quantum Excel what I have so they can help me pick the right design. In this case, the 2 inputs, firing angle and cup angle, are both quantitative. So I'm going to click on No, all factors are quantitative. And then Quantum Excel gives me a list of designs that would fit this appropriate design of which one I could choose. In this case, there's only one good design. It's a central composite design based upon a full factorial. So I will click on that, and then it asks me to enter the names and the lows and highs. The first factor is firing angle. So I'll replace A with firing angle. And then the low is 110 degrees, and the high is 130 degrees. And the next one is going to be cup angle. And the low is going to be 0, and the high is going to be 90 degrees. After I've entered the names and lows and highs, I'm going to click on Next, and Quantum Excel will ask me to choose the number of replicates. In this case, I'm going to do 4 replicates, so I will click on 4. And then I don't need to do blocking, and I'm going to leave the design format as table. I will explain in a later video what the difference is between table and stacked. It turns out you can change that after you create the design, so there's no need to edit that right now. Then I click on Next, and Quantum Excel asks me to choose the number of center points. The number of center points is a interesting discussion. I'm going to choose to put the number of center points as 2, and then it also asks me to choose the alpha value. The alpha value can be calculated for you automatically. If you want to optimize orthogonality, then you would click on Optimize Orthogonality, and it would choose alpha is equal to 1.0781. If you want to maximize the rotatability of a design, then you would click on the rotatable, and it would calculate that at 1.41. In the real world, I've found that most DOEs have a alpha is equal to 1, and that is called a face central composite design. I will choose to click on at face central composite design, and then click on Next. And then Quantum Excel asks me the number of outputs. In this case, I have 2 outputs. I have the red ball and the blue ball. So I change the number of outputs to 2, and I change the first one to red distance, and then it is quantitative. And then the other one is blue distance, and it is also quantitative. I should note that you can change what kind of output it is. If it happens to be binary, so a pass, fail, or good, bad, then when you select binary, when you run regression, Quantum Excel would automatically run binary logistic regression. If you chose nominal, then Quantum Excel, when you run the regression, would automatically run nominal logistic regression. And if you choose quantitative, then when you run the regression, Quantum Excel will run ordinary least squares regression. Then I'm going to click on Finish. And when I click on Finish, Quantum Excel is going to create the design for me. Quantum Excel tells me in the upper left-hand corner that it is a central composite design. The base design is a full factorial. So it turns out you can create central composite designs from half factorial as well. This one was not created from half factorial. This one was created from a 2 to the 2 full factorial. It tells you that you have 2 factors and 10 runs, and then the total center points are 4 replicates times 2 center points, so we're actually getting 8 replicates, and then I chose an alpha is equal to 1, and then down it tells me the number of replicates as well. On the left-hand side is the design. It is currently not randomized. There's obviously multiple features in Quantum Excel that will help you randomize it, but you can see the pattern here is that the firing angle is low, low, high, high, and then low, high, low, high, and so that portion is a 2 to the 2 full factorial. Then you can see that there is a low, high, and this is a center point, or I shouldn't call it center point. The cup angle is at the center, in which case this is going to be an axial value. And then this one is going to be at the center, and then firing angle is going to be at the center while cup angle goes low, high. So these are the axial values. And then finally, these are actually the center points. So there's 2 center points, and the center points are going to be denoted by the word center point. On the right-hand side, you can see where you can enter the data for Quantum Excel. So this is where you enter the data for the red distance. This is where you enter the data for the blue distance. You can optionally enter spec limits. So the upper spec limits and lower spec limits are there. The spec limits are required if you want to do CPK or defects per million based optimization. And we're going to get to optimization in a later video, but for now I'm just going to leave those blank. And then I would type the data into the spreadsheet when I start collecting data for the red ball and the blue ball. It's important to note that there are 4 replicates in this particular design. So there's rep 1, rep 2, rep 3, rep 4. Some other software packages start at 0. Quantum Excel doesn't really start at 0, it just starts at 1. So when you say you have 4 replicates, the first one is numbered 1, then 2, then 3, then 4. So we're going to need a grand total of, since there are 10 runs, we're going to need a grand total of 10 times 4, which is going to be equal to 40 data points for the red ball and the blue ball. And that is how you set up a design in Quantum Excel.